solve this instructor session today for week 4. Are you there? So, shall we wait for some other participants or they left? Only I'm seeing here
Yeah, they
only
left.
39
Please
participants
go
are.
ahead.
So,
Yeah, it
how
was
many were there? Do you have
it
any
was
idea?
it was just 16, 10 minutes back. Now the participants got improved. I think it's a good time to start.
Yeah, so is it like the same number of participants or it was more before? Do
Yeah,
you
it's
have any
more.
idea about
It
it?
increased.
It's more.
Number of
Huh?
participants increased.
Same, sir. Around 40, 40.
No, it is
Okay, okay,
increased. It is
then
increased now.
now it is increased. Okay, fine, fine. So we'll start. Okay. So if anybody wants to join, they will
Yeah.
join later some part of time, right? Okay. So yeah, today we are not using this. What do you say? Joinpd.com. Instead of that, you can answer me in the chat box. But don't answer it to everyone. That send to everyone is there, right? Just do it as to what do you say? Statistics one privately. There is no option, right? Is there? Yeah. So there you can see in your chat box. Just
Yeah.
change that setting to.
It is advanced
sta-
POs.
Yeah, another
It
one host will be there, right?
advanced pivot.
The statistics one.
Yeah, there is a statistics one, sir. There is a statistics one.
Statistics one. Huh. So
Yeah.
just what do you say? Just change that setting to statistics one. Now that's sent to everyone, right? Instead of that, just change it to statistics one and send me the answers there, right?
Sir,
Okay.
not
No,
Fine.
the choice.
this
uh,
one.
It will be
Not
there, right?
option. I only have one option that says chat with everyone.
Oh, is
Uh,
it?
Go to the
So
right,
you
like
don't
that down arrow.
there will be one. See, the chat send to everyone. Just click on that. The send to everyone. You'll be getting a lot
No,
of.
I have chat
Uh,
with everyone. Then the chat box opens. There are no settings inside the chat box for me.
The drop down you can
see,
find that in the drop down.
can you
Chat
click on that
box.
everyone? That means there is some arrow kind of thing, right? It should be
No, I
there.
don't
The
have.
right side. Oh,
Maybe it is
wow.
only for
Are you using laptop
getting
or
access.
mobile?
I'm using mobile.
Okay. Still, it should be there, right? Okay, okay. So what we'll do is, okay, you can send it to everyone. It's fine. It's okay, right? You just send your answers, uh,
Okay,
right?
fine.
And okay, fine. So I'm sharing my screen to you now, guys. So yeah, is it visible?
Yes.
Yes.
Okay, okay, fine. So yeah, we are not using today this joinpd.com. So this is the first question from week 4 grade assignment is in front of you. So here you need to give your answer as A or B. It's like option A or B. So question number 1 is if the values of the explanatory variable, that means x value, is high and the corresponding values of the response variable y is also high, then x and y are positively correlated or negatively correlated. So you need to enter your answer as A or B. So just type your answers into the chat box. So I think this is very basic question, and answer is should be simple. So we are not taking a lot of time in this question, right? So I'm going to check what answers you have given in the chat box. Okay, okay. So I'm seeing a lot of people are giving answer as A. Some positively correlated A. Some of them. Okay, I'm not seeing any B here. So all of you are agree that it should be positively correlated, right? Okay, and someone said that as both are high, it will go on positive, right? So, okay, okay, guys. So we'll see the solution. I think you guys got this thing correct. So yeah. So this is the okay. I'm introducing you here this concept of covariance before going to this correlation. So covariance quantifies the strength of the linear association between two numerical variables, right? It quantifies your strength. Quantifies, that means it gives you a numerical value, right? Some 2, 4, 6, or -2, -4, -6, like that, and it gives you the strength of the linear association between two numerical variables. That means. So it quantifies it. It doesn't qualify, but it what you say quantifies this. That means it gives some values of this linear association between the two numerical variables. And the population covariance for n observations is given by summation of x, that the summation of the products of the deviations. So what is the deviation? The x deviation, that means the deviation of that x variable from its mean, and y deviation is the deviation of that y variable from its mean. So it is the sum of the products of the deviations of two numerical variables, and we are taking its sum from 0 to n, where capital N here is the number of observations in a given data set. So it's the population covariance is given by summation of x minus mu x into y minus mu y, and sum goes from 0 to n divided by n. Similarly, the formula for the sample covariance for small n observations is given by the same thing in the numerator, but there is a one change in denominator, as it should be n minus 1. So let's say there are small n samples, small n number of observations in a given sample. To calculate the sample variance, you need to take the product of these deviations from 0 to until that number small n number of observations. But here we need to take a precaution that we need to divide it by n minus 1, right? So we'll try to see this, how it is positively correlated and how it is negatively correlated, right? So see, in front of your screen you can see there is x on the x-axis and the y is the on the y-axis. So that means x is here is your explanatory variable, and y is the response variable. Both of these are the numerical variables. Okay, x is also shows you a numerical variable, and y is also a numerical variable. So as this, you can see any, if you are able to see my what this cursor, you are able to see, right? So here you can see this red dot what I am showing through this cursor. Let's say it is having this value corresponding to x here. Suppose it is 2, and the corresponding y value is here, it's 2, right? Now let's suppose I'm increasing the x value. So let's say I have increased from x value from 2 to, let's say, 6. So suppose this is my uh, dot, or this is my data point corresponding to the variable 6, corresponding to value of 6 for the explanatory variable. So you can see there is increase in the y value as well. That means as you go from smaller value of the x to the higher value of the x, your corresponding y value also increases from the smaller value to the higher value. That means it is the positive correlation, or you can say positive covariance it is showing here, right? Similarly, the negative covariance, you see, the negative covariance, what happens is, suppose this is my data point. So the x value corresponding to this data point is 2, and the y value corresponding to this data point, let's say 4. So as I have increased my x value from 2 to, let's say, 6, my y value corresponding to it decreases to, suppose, it 2. That means, in if the two numerical variables are negatively correlated, then as you increase the value of explanatory variable, your corresponding uh, value of the response variable decreases. But in positive correlation, what happens? As you increase the value of this explanatory variable, your corresponding value of response variable also increases, and vice versa, right? So those people who have answered it is the for this question, that as your explanatory variable x is having high value and the corresponding response variable is also having the high value, then x and y are positively correlated. That means option A is the correct answer. Okay.
Can I
So
ask a
this is the
question?
next question. Yeah, yeah, yeah.
No,
You can ask this.
can you please go back to the chart?
This
Okay.
one, right? Yeah. Yeah.
Yeah, yeah. These data points are all mapped against x and y set.
Right, right.
Then why x bar and y bar is given?
Yeah, okay, that x bar is the mean of the data, and y bar is also that, say, x bar is the mean of this x variable, and y bar is the mean of this y variable. So you can see the, for example, let's say x bar is some value, will be having some value x bar here, and will be having some value of y bar here. So we just can say that, suppose this is y variable, right? The y bar value.
No, no, no.
So
No, no. What
these
I'm
are the data points.
no,
Yeah, yeah.
no, no. The question here is these things are all data points as it is given.
Okay, right.
And you are
Those
including an x bar
dots
and
are
y
the data point.
data points, okay. But x bar and
Correct.
y bar is included for what
Uh,
purpose? For what purpose?
Here, just showing this representation, right? This y bar, you can, I can remove it also, but it is just for to say, let's say this is the y bar, something y bar is there. So some of the data points are above that y bar, like these data points are above this mean value, and the below ones are the below this y bar. So it is not for this. It is not related to this question. Okay, this
Okay,
x bar
okay.
and y bar it's there, but it's not related to this question, right?
Even otherwise also your explanation is right without x bar y bar.
Yeah. If you remove
Yeah.
this x bar y bar, it doesn't matter. So it's just
Okay.
to represent here. It's not related to this question, right?
Thank
Okay.
you.
So this is the question number one. Sorry, prelude one to the question number two. So you have given the data set here where x variable takes these values 98, 85, 90, 85, 95, and 75. Similarly, y variable takes these values. So both are these are the numerical variables. Just find the mean of the x and y. Okay, so I will give you some, and okay, so just remember this is prelude one. So prelude one, that means we'll be using the same data point, sorry, same data set until the question number two. So whatever things are you calculating, just write it down somewhere, because we are using those values, right? So that your time for the calculation will be reduced for the question two. So yeah, just compute the mean for x and y. So you have to calculate two different means. One is x bar, and another one is a y bar. Okay. And while giving the answer to the chat box, just mention x is equals to your answer and y is equals to. So I will be considering it as the x bar, and for y as y bar. Okay.
correct my understanding. For my for the mean, we don't have we don't have sample and population. No? There is no differentiation for the mean calculation.
So if you say sample mean also, yeah, calculation it won't change. It will be same for sample mean also, and sample mean and population mean are calculated by the same formula.
So n and n minus 1 concept won't come for mean.
Right. No.
So for mean, everything is n, n, is it not?
Yeah. How many number of observations are there? That will be there for calculating.
I have a general, means I have a doubt on week 4 actually. Till we move to the next, this one slide, can I ask that question?
Uh, no, we'll take that. You said
Later.
it's like related to the questions or related to concept. What's
Concepts,
there like
concepts only.
concept related to which
No, we have
which
in
concept?
week, no, covariance is there, correlation is there, biserial correlation is there.
Right.
So covariance, covariance will range from -1 to +1. And
Okay. This is kind of doubt. Okay, then at the end of the session we'll take. That
okay,
means
okay,
at the end of session I will
okay,
give you the brief summary
okay,
about it. Okay.
okay.
Right. Okay. Fine. So I'm not able to see how many people has given the answers. So should I give you guys some time or is it done?
It's done,
If
I think.
anybody remains, no,
Proceed.
whoever is done is fine. If somebody is there who wants time also, just tell me. Or should I move to the solution?
Please proceed, sir.
Okay, so yeah, so I'll see how many people have given the answer. So yeah. So okay, Ankit has given 460.5 for x. That means you have just calculated x bar. I told you to calculate 2, right? Some So someone has calculated only 88. That means only x bar, not the y bar. X bar is 88, y bar is 11, x bar is 89.43, x bar is 88, y is 11. Someone okay here. So there are a lot of variations in the answers. Most of the people has given 88 and 11, and some of the people have given only the answer to the x bar, and some of the people didn't give the answer to y bar. Y bar is 66, 88, 88, 11, 88, 11, 11, 88, 11. Okay. Okay. So, sir, I didn't get it. So, you didn't get the question you were saying, right? Okay. So, we'll move to the solution of this question. Okay. So as you see, there are two variables. X is a numerical variable and y is also a numerical variable. And this is the data related to the x variable and this is the data related to the y variable. So I asked you to calculate the mean for x and y. That means you will be getting two different means. One is x bar and another one is y bar. So what is the general formula to calculate the mean? The the general formula is summation of summation from 1 to n, right? And xi means, like, let's say these are the number of observations which are going from 1 to n divided by total number of observation. Similarly for y bar also, we have to take the sum from y1 to yn divided by total number of observations, right? So yeah, so revise we are see this concept of mean was there in the week 3, so we are revising this concept of mean. So as I said that the mean is the average, like mean is the what is it? Mean is the division of sum of observations to the total number of observations, right? Here you can see the sample mean or the population mean, whatever you can say. The sample mean for the n observations is given by x1 plus x2 plus x3 until xn divided by the number of observations in a sample. Similarly, the population mean for n observations is given by mu is equals to x1 plus x2 plus x3 up to xn divided by n. So here you can see that there is only the difference of uh, symbol. For example, the sample mean is represented by small x bar and the population mean is represented by mu. This is the only difference. Otherwise, the formula is same. There is if small n observations are here, you have to divide by small n, and if capital N observations are there, you have to divide it by capital N. That's the only change. Otherwise, there is no change in the formula. Like covariance, we saw earlier that for the sample covariance, we need to divide it by n minus 1, right? But there is just change of these symbols. So sample mean is represented by x bar and the population mean is represented by y bar. So in this data set, if I wanted to calculate x bar, we need to add 98 plus 85 plus 90 plus 85 plus 95 plus 75. And how many observations are there? Total of 6 observations are there, right? So you have to add all these observations and you have to divide it by 6. So we'll get the x bar. Similarly, for y bar, we need to add this all 6 observations corresponding to y, that is 15 plus 12 plus 10 plus 10 plus 12 plus 7 divided by 6. So that's how we have to calculate the x bar and y bar. So here in this slide you can see x bar is calculated as 98 plus 85 plus 90 plus 85 plus 95 plus 75 divided by 6. So the answer for x bar is 88. Similarly, the answer for y bar is 15 plus 12 plus 10 up to 7 divided by 6 is equals to 11. So those who have given the answers 88 as x bar and 11 as y bar, it's correct. Some of them has given the answer for x bar only and some of not given the answer for y bar. And those who have given the incorrect answers, just see this how we have calculated and improve for the next time, right? So I will ask every, yeah.
Can we listen to someone who has given 87.5, because everybody else
No,
also
no,
could
see,
possibly will say the same concept, no?
uh,
Let's give him a chance to
but
talk about.
if he wants to talk, then if or he or she wants to talk, then
That,
only.
yeah, yeah, that was my mistake. Instead of 528, that 8 looked like 5 to me when I was working out. So it was a calculation.
Okay, okay, calculation mistake, right? But some of them has given the some different answers, like 238 I have seen.
Yeah, three-digit
Your
number, it's
choice.
really
Yeah,
confusing.
yeah, we need to,
So,
yeah,
but it's
we need to
okay
listen
if you
to,
do, if you have done the mistake, it's fine. But just have you got this concept? This is important, like how to calculate the mean. So I don't want them, okay, without their wish to how they have calculated. If they are able to convince with this answer, then it's fine. Otherwise, they can ask the doubt here, or they wanted to how they have calculated. They can tell. So anybody wants to
yeah,
share the how this different answers have come there?
yeah, that would be the good thing.
Hello, what happened? So others also have this problem.
No, we could see.
No, sir.
I can see your screen.
So
I think
maybe
internet problem.
I don't know. Yeah, internet connection problem maybe. So just check where you'll get strong internet connection and there you can see. Okay.
Yes, Sakshi, just try
In
like
general, you
leaving the
guys,
meeting and joining again. I think it will solve something.
yeah, that also might be work. So you can leave the meeting and join it again. So it might work. Yeah. So yeah, other guys who have given the incorrect answers or those who have given the correct answers also, you got this concept right, and just write down these numbers. So you have got this x bar. That means the mean for the this x variable is 88 and the mean for the y variable is 11, right? So we are moving for the next question. So again, this slides repeated slide. Okay, yeah. So this is the question number 2, right? So this is the same data, whatever I told you, this is the same data, but here instead of calculating the mean, you have to calculate the covariance for this data set, right?
Sir,
So I'll give
covariance of
you
what? It is
x
for
and
sample or
xy.
for population?
Okay,
Is
so
it just
I'll
me or
just
like the voice
oh,
of sir is muffled a bit?
is it not coming properly?
Sir, it is for population or for a sample?
No, for
Yeah,
me it
yeah,
is
yeah, yeah,
muffled.
I understand your. Okay, 1 minute. That one guy is asking that what is the sample covariance or population's covariance? Are you able to hear me properly, everyone?
Yes, sir.
Yes, sir.
Actually, I am asking that
Now it's right.
whether we have to find covariance of sample or population.
Okay, so okay, for this question, calculate it for the sample. So it's my mistake. So yeah, compute the value for the sample covariance for this given data. And for your information, okay, calculate for both sample as well as population, and similarly write S as the sample covariance, and let's say Y as not Y, Z as the population. So in the chat box, while giving the answer, S as the sample covariance and Z as your population covariance. Please enter these answers. Okay. Right.
Can we see the
Calculate it for
formula?
both.
Can we see the formula? One time we see.
Okay. 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 So see the formula. It's there in front of your screen. So just write it down somewhere. Okay. Then I'll move to this data set again. See, if I give you the formula, then there is nothing, right? It's just a calculation. Okay, it's fine.
Yeah, it's calculation, but whether it's square is there or not, that's the thing we want to get confused.
Okay. So it's fine, right? This formula is okay. Okay. So calculate it and calculate for both sample as well as for the population.
Sir,
Yes.
sir, I have a doubt for a question.
Hmm?
It is
Hmm.
different from this table. So can I ask it now?
From where? Like, yeah, you can ask. Let me see. Oh yeah, tell.
Sir, there was a question. It asked that there is a data for consecutive 10 days. So
Hmm.
do we have to take the days in X, or we just have to calculate mean from its frequency? Like just take it as individual series, not the discrete series.
No, I didn't get your what we are going to calculate. What you have
Sir,
asked for calculation?
sir,
You have
question
10 days
was,
data.
yes, sir.
Number of days is given.
Consecutive 10 days, 1 to 10. And there was
Okay.
a series of numbers 15, 12, 10, just like this. So do we have
Hmm.
to separate both the series like 1 to 10 and then the other series, or we just have to calculate the individual series that is given in the question? Because the
No, no. What are
consecutive
you going to
days,
calculate? Mean? No, no. What you
yes
want
sir,
to
mean,
calculate?
mean.
That I want. Mean. Okay. For mean, you're saying, right? So yeah, mean will be separate. It will be separate for separate variables. So your mean for the number of days will be the different than the mean for the whatever the other variable will be. I don't know what variable is there. So if you have two different series of numbers,
Yes sir.
you will be having two different means, right? So you have to take separately. It can't be the both, like, unless and
Multiplication,
until it is, yeah, unless and until it is mentioned that this is the what you say frequency for the corresponding variable.
day.
For example,
Yes sir.
x is my variable. Let's say if you are rolling a die, right? So you will be getting outcomes as 1, 2, 3, 4, 5, 6, right? And
Yes sir.
I'm rolling a dice for several number of times. Let's say 200 times. So how many times I got the one? So it is the frequency related to one, right? In that case, you have to calculate it by summation of fi into xi divided by summation of fi. That formula you have to use, right? If
Yes,
the
sir.
both are, yeah, if these both series are different variables, that means they are not, you say, not, I won't say dependent or something, but I'll say these are the different things. That means it is not, the other series is not representing the frequency for the first series.
Yeah, they are
In
not
that case you
related.
have to calculate the, yeah, if it is
Yes,
not
sir.
there, in that case you have to calculate for the separate means, right?
Okay, sir.
Yeah. If the frequency is given for some variable, then you have to consider it as while calculating. But if it is not there, then it's not needed.
Okay, sir.
Okay. So I'll be back in 2 3 minutes. I'll take some water. Okay. So until that, write your answers in chat box. Calculate for both rate, sample as well as population, and represent sample as S while writing your answers, and Z as population. Okay, guys. Is this time is enough, or you want some more time?
Yeah, I think we can go ahead.
Sure, everyone.
No, sir.
Okay, 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 okay. Wait, I'll wait for 2 3 minutes more. Okay. Is it done?
Yes, sir.
Okay. So in between, I'll see the answers. Okay. Can you share this slide? Somebody said, yeah, we'll be sharing, right? Every time we'll be sharing. So okay. Uh, I'm getting some answers. S has 19.4 and Z. That means sample mean is, sorry, sample covariance has 19.4 and 16.66. Okay, okay. Variance. Okay. But this is not the variance, okay? This is covariance. So sample covariance as somebody has written 16.616 as sample covariance and population covariance as 19.4. Okay. Okay. 10.33, 12.4, 21.4, 17.83. So yeah, this time I'm getting different answers for the sample and this population covariance. Okay. 19.1, 16.53, right. Sample is 9 point minus. Oh, somebody's got minus 9.4 and population is minus 7.8. Okay. So okay, I will go to the solution. I think the answer is sample covariance is 19.4 and your population covariance is 16.16. So those who have given these answers, they are correct. And for others, we'll see the solutions. And one more thing. See, the basic thing is, if you are calculating the sample covariance, right, you will be dividing that sum by n minus 1, right? So when you are dividing and for the same data, if you wanted to calculate the population covariance, you are dividing it by n, right? So n is greater than n minus 1, that is true, right? So when you are dividing the any, what do you say, numerator by the same numerator by some smaller value, your answer to this division will be higher, right? So your sample covariance will always be higher than your the population covariance. So if this condition occurs, that you, if you are asked to calculate the sample covariance and the population covariance for the same data, then your sample covariance should always be higher side, on the higher side, right? Because you are dividing it by a smaller number, right? So I saw one answer. He or she has given, I think it's opposite. Your the values are correct, but the he has given the population covariance higher than the sample covariance. So maybe due to the calculation, right? So yeah, we'll see the so this is the table, because we need to calculate this product, right? X minus mu x into y minus mu y. So for that, what we have done is, we have constructed a table, and this is the same data set here. X has 98, 85, 90, 80, the same data set. Then this x minus x bar is, because I told you before, you have to, 88 was the x bar, right? If I'm not wrong, yeah, 88 it was your x bar. That means the mean for the x variable, and the 11 is the mean for the y variable, right? So what we have done here is, from the each observation we have subtracted this sample mean, right? So 88 was your x bar, then 98 minus 88 is equals to 10. 85 minus 88, it will give you minus 3. 90 minus 88, it will give you 2, right? 85 minus 88, it will give you again minus 3. And 95 minus 88, it gives you 7. Similarly, 75 minus 88, it gives you minus 13. And the mean for the y variable, that is y bar, was 11. So 15 minus 11 is equals to 4. 12 minus 11 is 1.
So 11, 7 minus 11 is equal to minus 6, no?
Products. So we need to add 40 minus 3 minus 2 plus 3 plus 7 plus 52. If you add these numbers, you will get this numerator. Right? And I asked you to calculate the both sample variance, sample covariance and the population covariance. The only difference is you are dividing it by 6 when you are calculating the population covariance, because here total number of observations are 6, and when you are calculating this sample covariance, you need to divide it by 5, that is 6 minus 1. So your numerator will be the same in both the cases, that is the sum of these numbers, right? So let's see, the sum of these numbers is 97. So when you divide it by 5, you'll get 97 divided by 5 as 19.4. And similarly, if you divide the 97, 97 by how much? 6. You'll get
6.
16.16. Correct? So your answer is sample covariance is 19.4 and the population covariance is 16.16. Right? So you can see here your sample covariance is greater than your population covariance, right? Because we are dividing it by a smaller number while calculating the sample covariance. So others who didn't get the correct answer, just check once again your calculations, right? And if you have any doubt until now, you can just ask related to this question or the concept.
I have a question on the question itself. Here in
Okay.
this question, you have not specified exactly what is the
Yeah,
covariance
yeah,
expected.
yeah,
Is
yeah,
there
yeah,
any
yeah.
default? Since you're online and we are able to ask you that you
Yes, yes.
clarify in the real
Yeah.
exam, in the qualifier exam, if I get the
Mm.
similar question. So, what is the default we can look into? Is it the
So
population or a sample?
yeah, yeah. So what I will suggest is it should be population. If anything is not given, you should go for the population covariance or population correlation coefficient, whatever it will be. Not sorry, not population correlation. It won't be there, but any population variance or population covariance, you should go for the population, not the sample. Okay, by default, if it is
That-
not mentioned. Right.
Okay, default is a
But
population.
most,
Yeah,
yeah, go for population.
the default is a population. If it is specifically
Population.
specified as a sample, then we need to go for a sample.
Right, right, right.
Okay,
But
okay.
it won't be there because we will take care of these things that this should not be happening. Okay, here it's happened because of maybe some mistake. But then in the while preparing this qualifier paper, we have taken care of these things that it should not happen. Okay.
Yeah, but the default is
So
the
you
population.
yeah, yeah, yeah. If it is happened, you by default you consider it as the population. Okay.
Okay, okay. Thank you.
Okay. Yeah. Thank you. So the answer should be sample covariance as 19.4 and the population covariance as 16.16. Okay. So we'll next move to the prelude one to the question 3. So the same data is here again. Okay. Here you have to calculate the sample variance for x and the sample variance for y. It's not the covariance. Okay. Sample variance. Sample variance of x and sample variance of y. So I'll be giving you 5 to 10, okay, 7 minutes from here, or 8 minutes, 9 minutes from here. So for 15, we'll discuss. Or if you wanted more time, at that point of time, we'll see.
What
So you
sample
need to
or
calculate
population? Sample or
sample.
population?
It's written here, right? It's written here.
Yeah, okay,
Sample
okay,
variance.
okay, okay. Okay,
Sample
okay.
variance for X and sample variance.
Excuse me, sir, I have one question. Can I ask?
Yeah. Yes. Yeah.
In association between two categorical variable, it is said that if row relative frequencies are same for all rows or column, then the two variables are not associated with each other. So why it is written same? Why it is not written similar? I think when I see the data, I see those
Yeah.
variables
Okay.
are,
Okay. Yeah,
yeah.
correct, correct. So you are saying that why it's written same there, but it should not be exactly same.
Mhm.
It can vary from here to there. Like let's say 22 is some one rose frequency is there. Somewhere it is should be 22.14, or the later one is, let's say, 22 point or 21.96 or something. It is
96.
somewhat
Yes.
closer to the some number, right? So it
Mhm.
should be like this. Similar, you can say. Similar is a different kind of
Similar
word,
is
right?
like we
Similar
cannot
is
say the
like,
same.
yeah,
Like
we cannot
same
say
is
the
not
same, but we
possible.
cannot say the similar also. Similar is not the correct word for this. Similar is kind of, let's say, two triangles are similar. That
Yeah,
means they,
their size might be different, but they look
yeah,
same.
yeah, yeah. But here you can't say this. Similar, like
Yeah. They are.
22.14 is not similar as 21 point something, right? Same in the
Mhm.
sense, approximately same. Approximately,
Yeah.
if you
I
take the
think if I
closer
add,
look,
uh
yeah.
if I
So
add
it should,
approximately
you
same,
got,
it will be.
yeah, yeah, approximately, if they are around some number, that means
Uh,
you can consider it as the same. It's that meaning there, right?
okay, sir. Thank you, sir.
Yeah. Okay. Okay.
Sir, I just joined actually.
Yes.
So may I know, sir, where can I
Okay.
answer the question, sir? And can you provide the link for me?
No, no. This time we are not using join PD. So you just write your answer in the chat box. Okay.
Okay, okay. Makes
So
sense, sir.
here,
Thank
yeah, yeah. So here I asked you to compute the value of sample variance of x and y. Just write x, and x is equals to your answer, so that I will be getting that this is the sample variance for x, and y equals to something. Okay, you understand, right?
Okay, sir. Okay, sir. All right, sir. Thank you, sir.
Yeah, yeah. Okay, okay, fine. So yeah, so you have very few less time now, because if you are joined now, so you, okay, I'll be waiting for 15, and then we'll see how much time it will be there.
So, sir, will you after the say, this question time
Session.
like over
Okay.
session over, so will you
Okay.
try to solve this problem like somebody like I might make mistake okay in the answer. So will you be
Yeah,
solving?
we'll be giving the solution. Yeah, it will solution will be there. So it's not
Okay,
like okay, the next question won't be there. Yeah, we'll see through the solution. We'll go through that solution and we'll try to see where you done the mistake or if you have done the correctly, you will get to know. Right?
okay, okay. Thank you, sir.
So do you guys need more time or is it done?
Yes, sir, done.
Answer.
Okay. So anybody wants some more time? Okay. Please don't write it in the chat box because I'm not able to see chat box now. So just you can unmute yourself and say, okay. So maybe I don't know. Let's see once. But very few people has answered this question. I'm seeing. Okay. 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 Okay, so we'll see. We can see here the sample variance for x is 68 and y is 7.2. So 68 and 7.2 is the okay. Somebody said 56.67 and 6. 68 and 7. 68 and 7. 68 7.2. 61 7.2. 68 7.2. 68 7.2. 68 7.2. So most like every lots of people has given the 68 as sample variance and for x and 7.2 as sample variance for y. Some of the people has given some different answers. Okay, 1.50, then okay, some sample covariance. I didn't answer ask you the sample covariance, right?
Yeah, this is a misunderstanding happened actually. So yeah, my
Yeah,
mistake.
okay, okay. Okay, fine, fine. So 68 and 7, 68, 7.2, 19.4, 19.4. So I think, okay, again, okay, I understand. So 68.7.2, okay, okay, okay. So yeah, the correct answer, we'll see. Okay, so the correct answer is 68.8 or 68 and the sample variance is 7.2. Okay, so those who have given the 68 as a correct answer and 7.2 they are correct. So we'll see how to go through this solution. So first of all, these are the formulas related to the variance and the standard deviation. So this is the same formula we have discussed in the last solve the instructor session last week, right? So again, we'll go through these formulas. So population variance is given by sigma square. Sigma square, you can represent the population variance by sigma square, which is equals to sum of summation of x minus mu whole square divided by total divided by n. So you need to square the subtraction between the data point from the mean, and you have to square it up, and you have to add all this what you say like in the numerator you have to add all these calculations, right? And you have to divide it by the number of observation. Similarly, the sample variance is given by s square, which is equals to x minus x bar whole square. You have to take all the sum of this term divided by n minus 1. So you just be very careful while calculating the sample variance. We have to use n minus 1. So population standard deviation is just the square root of the population variance. It's not needed here, but for the understanding of you people, the sample standard deviation is s, it is the square root of this term, right? So you can see, if you know the formula for the population variance and sample variance, then you can take a square root of it and you will get the formula for the population standard deviation and the sample standard deviation, right? So, okay, the question was we need to calculate the sample variance for x and y. So, sample variance, that means we need to use this second formula, s square is equals to summation of x minus x bar whole square divided by n minus 1, right? So, for that we need to calculate this x minus x bar to the square, this term, right? And we need to take the sum of all these terms, right? So, this is the table where x and y values are given here. We have calculated the deviation of x. So x minus x bar, same thing which we have done in the previous problem. Similarly, y minus y bar we have calculated here. So we know the x bar was 88, right? So we have subtracted 88 from this x. Is 98 minus 88 equals to 10. 85 minus 88 equals to minus 3. So I have explained it before. So we have calculated this deviation. Similarly, y was 11, so we have calculated the deviations here: 15 minus 11, 12 minus 11, like that, right? And for to know the sample variance, we need this term, right? X minus x bar to the whole square to calculate the sample variance for x, and y minus y bar to the whole square to calculate the sample variance for y. So we have squared these numbers. So 10 square will be 100, minus 3 square will be plus 9, 2 square will be 4, minus 3 square will be plus 9, 7 square will be 49, minus 13 square will be 169, right? Similarly, y minus y bar. So we have calculated this deviation. We need to just square these terms. So 4 square will be 16, 1 square will be 1, minus 1 square will be plus 1, minus 1 square will be plus 1, 1 square will be 1, and minus 4 square will be 16. We need to take the sum of these terms and sum of these terms to calculate the sample variance for x and sample variance for y. So what is the sum of this? 100 plus 9 plus 4 plus 9 plus 49 plus 169. The sum is 344, right? So, okay, 1 minute. I'll just check once the sum. 100 plus 9 plus 4 plus 9 plus 49 plus 169. So, I think it's wrongly. Okay, uh, it should be 340, right? 100
Yeah,
plus 9 plus 4,
340 and
right? Okay.
36.
Right. So it should be 340. It's correctly mentioned here 344. It should be 340, right? And
Yes,
to
sir.
calculate the sample variance for the x, you need to divide it by the n minus 1. So total number of observation here are 6, right? 1, 2, 3, 4, 5, 6. So you need to divide it by 5. Correct. So 340 divided by 5. So your answer should be
68.
It is 68.
Hello, sir, you are not audible. Hello, you are not audible.
So okay, guys. So we'll see how many answers I got. 8.24 and 68, 2.68. Okay, 2.7, 2.6. Okay, that only this many. Are you not able to hear me?
You can, sir.
A moment
Now
we
I
lost
can.
You're
you,
audible, sir.
but now we can hear you.
Yeah. So okay, I got only few answers here. Okay, I'll just wait for one more minute. See, it is just the sample standard deviation. I showed you this formula right before. This formula you have to use. The fourth one, s is equals to root of x minus x bar, summation of x minus x bar whole square divided by n minus 1. So this formula you have to use. Okay, okay, guys, that's it. So okay, 8.24, 2.68. So I'm getting the uniform answer for this question at least. Okay, so this was nothing but we need to take what the previous question we have calculated the sample variance for x and sample variance of y, right? And the answer was 68 for the sample variance of x, and for sample variance of y the answer was 7.2. So what you have to do was just you need to take the square root of these answers. So that means square root of 68. Square root of 68. So if you take the square root of 68, what will be your answer? It should be 8.24, right? And the square root of 7.2. Square root of 7.2. The answer should be 2.68. So here the same thing I have written here. See, the value is wrong here. The variance of the standard deviation for, sorry, the standard deviation for the sample standard deviation for the x is not root of 68.8. It should be root of 68, and the answer is 8.24. And for this sy, the sample standard deviation for the y variable is root of 7.2 s 2.68. So those who have given the answer as 8.24 and 2.68, it's a correct answer, right? So I think we have to and note this down also, because we are using the sample standard deviation in the next question. So just write it down. The sample standard deviation for the x as 8.24 and sample standard deviation for y as 2.68. Correct? So before moving to the next question, we'll see the concept of correlation. So you know the concept of correlation between, that means we are going to measure the linear association. So this term is important. The linear association between the two variables. That means if there are two numerical variables, we are going to uh, have we are measuring the linear association between these two numerical variables. That means these points are how much um, for example, if it is a perfect correlation, that means the value for correlation is 1. That means these values, the corresponding values or the data points are on the straight line, perfect straight line, right? So the corresponding values of the x and the corresponding values of y, they show the strong association there when we'll be having the uh, correlation coefficient rs 1. And that means, and rs plus 1, that means we have the positive correlation. That means as the value of x increases, the value of corresponding value of the y should also be increases, right? And in case of the negative correlation, you will, the perfect negative correlation, that means when we are having the value as -1, your as your value of x increases, your corresponding value of y decreases, and vice versa. But they are on the perfect straight line. The data points are on the perfect straight line, right? And if they are deviate from the straight line, then the correlation coefficient changes. So we say the strong correlation between 0.75 to plus 0.75 to the plus 1, or minus 0.75 to the minus 1. It is the strong correlation between these two numerical variables, right? Similarly, if the values are lying between, the correlation coefficient values are lying between 0 to 0.25 in positive side, or 0 to minus 0.25 in the negative side, you will be saying that this is there is no association between these two numerical variables, correct? Or a weak association or a weak correlation between the two numerical variables. So the formula for the correlation coefficient is given by this summation from 1 to n, the product of the deviations, that means xi minus x bar into y minus y1 yi minus y bar. So you have to take the sum of these products of the deviations. So we have calculated the products of deviations in the previous questions, right? And divided by root of summation of I goes from 1 to n xi minus x bar to the whole square into summation of I equals to 1 to n yi minus y bar to the whole square. So this is the formula for correlation coefficient. Okay. Or
I have a
in
doubt.
yeah, okay, no, just a minute, I will complete. So the correlation coefficient can also be written as covariance of xy in the numerator divided by sample standard deviation of x into sample standard deviation of y. So by that also you can calculate the correlation coefficient r. This is just a, what is it, simplification of the formula. Because covariance formula is summation of this numerator whatever you're seeing divided by n, right? For the, let's say, population. And the sample standard deviation for x will be this, the term written here as xi minus x bar to the whole square divided by n minus 1, if it is the sample. And the sample standard deviation is yi minus y bar to the whole square divided by n minus 1. So what happens here is, if you take the square root of it, you will get the n minus 1 outside, and similarly you will be having n minus 1 from the numerator outside. It will get cancelled, and this formula will we'll get to know, right? We'll derive this formula from that covariance of xy divided by sample standard deviation into sample standard deviation for x into sample standard deviation of y. So for that you have to take the sample covariance in the
Why are
numerator.
we telling a sample standard deviation? Why do we need to tell a
So what
sample
I'm saying,
standard deviation?
what I didn't understand your question.
The denominator, we are telling that it is a product of sample standard deviation. Why
Not here.
it is
So I'm
called
what
a
I'm
sample?
no,
So just
this is not a sample standardization. What I'm saying is you can calculate
yeah.
the correlation coefficient from another formula as covariance of xy divided by
Okay.
standard deviations of x into standard deviation of y. So when you take the sample covariance in the
Yes.
numerator, you have to take the sample standard deviation in the denominator. That's what I'm saying, that from there it is
Okay.
derived this formula, because that
Okay.
n minus 1 will get cancelled,
Okay.
and you will get this
Okay.
formula.
Thank
It
you.
looks, yeah, that's what I'm saying. And if you
So,
take the population covariance, yeah.
Okay. Thank
so this is about the sample correlation covariance only, right? Because we
See,
have calculated the
core,
covariance for both sample and population. But the answer
yeah. So
here,
what I'm saying, see, correlation coefficient is not the sample and the population. It is only correlation coefficient. But if you take the see, I'm saying okay, you can calculate the R as R equals to covariance of xy. Okay, covariance of xy divided by standard deviation of x into standard deviation of y. So when you are taking the population covariance in the numerator, you need to take the population standard deviation in the denominator for both x and y. Okay, and
correct.
similarly if you take the sample sample covariance in the numerator, you have to take the sample standard deviations for both x and y in the denominator. So
That is
that's
correct.
the thing.
That is correct. But
Yeah.
for answer to answer this specific question, do we need to consider the sample or a population?
Take anything. See, it's not
Both
needed that
varies, right? Both varies.
no, see, that's what I'm saying. If you take the population covariance in the numerator and the population standard deviations in the denominator, the value will be same if you consider the sample covariance in the numerator and the sample standard deviations in the denominator. Because that n minus one will cut, so this term will be there. And
Understood.
similarly in the yeah, so your answer won't vary, but you need to consider that when you are using the population covariance in the numerator, you have to take population standard deviations in the numerator. There you can't do like this population covariance in the numerator and the sample standard deviations in the numerator. That you have to take care of. Okay.
Exactly. I got the point. Thank you.
Yeah, okay. So we'll move to the question. I think it's probably the last question. I don't know, but yeah. So the same data set is there. We have to calculate the correlation coefficient. Okay. So I'm giving you 5 minutes from here, because we are having the mean for this data as 88. That means for x variable the mean is 88. For y variable the mean is 11. So from here you just calculate the correlation coefficient. We have one more question after this, so just
Sir, I have a concept built on correlation, sir. Can I ask?
right. Yeah. Ask me.
Sir, where we will use this correlation, sir? I want an example. In which cases we will
Correlation.
use?
Okay.
Sir.
So let's suppose if you wanted if you know houses are there, right? If you go for like if you wanted to buy a house, okay, so
Okay,
which
sir.
things, let's say two variables I'm considering. One variable is area of the house and another variable is the price of the house. So area is dependent on the price, right? For example, and both area and price are the numerical variables. For example, let's suppose uh, the area of the house is 6, or a flat, let's say the area of the
Okay,
flat
sir.
is 650 meter square, and for that the price is, let's say like imaginary price I'm saying 10 lakh rupees in
Okay, sir.
certain area. right?
Yes, sir.
Then area of some plot is, let's say, 750 square meter, and the price is 12 lakhs. This say area is 850 square meter, and the price is, let's say, 13 lakhs. So what we are seeing here, as our the price as our area is increasing, the corresponding prices of these houses or flats are increasing, right?
Yes, sir.
So by using this correlation between area and the price, you can say that if it is positive, let's say it is plus one. That means you
Hmm.
can say, as my area increases,
Hmm.
right?
Yes,
The
sir.
similarly my prices are also increased. Let's say 650 meter square is square meter is, let's suppose it's a 10 lakh value, and the double of it
Proportionally
is
increasing.
1300,
After.
and double of it is, let's say, 1300 meter square, it's 20 lakhs. So you can directly say that there is a perfect correlation between these
Oh,
two price numerical variables. As my area becomes double, my prices
okay.
are becoming double.
Okay.
The inference you can take it from this, right?
Yes, sir.
So that's why we are using the another example. If I wanted to give is, suppose you have bought a bike, new bike. So the
Oh,
price for that bike is, suppose in the first year it is, suppose some 1 lakh rupees,
hmm.
and the second year if you wanted to sell it, how much you there will be some depreciation cost, right?
Yes, sir.
So let's say second
95,000.
year, let's say 95,000. The third year it will go to 90,000 or something like that. That means
Yes.
as your years are increasing, your value is decreasing.
Inversely proportional.
Yeah, so it is your negative correlation.
Okay, sir.
Right?
Thank you, sir.
So if you, yeah, so
Hmm.
there are a lot of examples. You can take any examples between
Yes,
two
sir. I
numerical
understood.
variables.
I understood, sir. Nice example. Yes.
So yeah, so I
Sir,
will
I
take,
want to add
I will
something.
give you, yeah, okay.
Yeah, can I add something? Sir,
Yes, yes, you can.
I have heard something about correlation. Um, like if
Okay.
for real problems, there are many variables, and we have to select certain variables for certain, we have to check which is dependent on which other. Something
Okay.
that
Yes.
there are three variables. For suppose there are three variables, and I want to select the best of the two variable. Then we use correlation to show that other two variables are better than the other. And how we do that? We do that
This,
through correlation.
see,
This is called as
yeah,
feature
you
selection
can
in
say.
machine learning.
Yeah,
Machine
yeah,
learning.
correct, correct. This is the data science problem. Like you can say, let there may be different variables. Let's say 4, 5 numerical variables are there, and some dependent variable, kind of like in the same example. If you take, right, this
Yes,
housing
sir.
price. So house price is not every time it's dependent on your area, right? There might be some
Yes,
different factors.
yes, sir.
So how that different factors are correlated with the final variable, and which
Mhm.
is mostly impacting your final variable. Like area is impacting more on the price, or let's say
Which
a
is
number
showing
of
effect on this,
rooms.
that you know.
Yes. So that is by given by the correlation coefficient, right? So
Mhm.
how your, see the same thing, as your prices
Mhm.
are increasing, so area is increasing, your price is increasing. That means increasing area is affecting your price,
Yes,
correct?
sir. Mhm.
It is affecting
Sir.
your price. So you
Mhm.
can take the inference from it, right? So okay, so
Yes,
I'll
sir.
be giving you. I don't know how many of you solve this. So I'll be giving you two more minutes. Solve it. I'll just be back. Okay. We'll see the solution for this, and we'll move to the next question. So everybody has got the answers, or shall we wait for 1 or 2 minutes?
Meantime, I have one small examination
Yeah.
related question.
Okay. Yeah. Okay. Okay.
So now we have around six data points.
Huh?
So, so by using the TCS calculator, no, when we calculate it,
Huh.
it's getting
It will be
difficult actually.
difficult, right?
Yeah, it is. I
Right.
mean,
Right.
sir, there is a very high chance that you do mistakes
Okay. Yeah.
because of the brackets and other things. Huh? So, can you
Mm-hmm.
restrict to five data points or something which is
Yeah.
see
Yeah.
here
Yeah.
because here the
Okay.
examination is for conceptual, no. So,
Correct. Correct.
so more data points is a very high chance that even if you do one mistake, you
Yeah.
my
Yeah.
answer.
Yeah. So yeah, yeah, I understand, understand. Yeah, that was the similar thing. So last time also, so we will consider these points and we will reduce the data points there. Don't worry about this. If such kind of problems will be there to find the correlation coefficient or something, this is a practice session. So here we will
No, that is
take
fine. Yeah.
more numbers, right? But in the
Hmm.
qualifier exams, it won't be there. Don't worry about it.
Maybe three or four because
Yeah,
three
yeah,
is too
yeah.
less. You may consider, but using that the
No, no, four.
calculator,
At
no,
least. Yeah, yeah,
even
four,
the
three or
three
four.
is also is difficult actually because now,
Difficult.
yeah, yeah.
Correct,
To be
correct.
very honest, if you use that calculator for three data points, it's equivalent to doing it with for 10 data points.
Yeah, yeah. So what I'll suggest you with the three also, if you wanted, but the this TCS calculator is available to you also, right?
Yeah, 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 yeah. Yeah.
Yeah. So what I'm suggesting you, okay, it's fine. Three, we'll reduce the data points. That's fine.
No,
But
I am
you
only
guys
telling
also
three,
practice.
but you can discuss and you can, but don't exceed five.
No, 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 no. That will be taken care of. So one, no. What I'm saying is, you just guys just practice on the TCS calculator. Means in while solving in your room also. Means if
Yeah.
you are doing some practice, right? Some practice
Yes,
problems.
yes.
So while doing that also, if you try practice on the TCS calculator without doing the calculations on the normal calculator or in the mobile, if you do there, you will get somewhat familiarized with that calculator so that in the exam you won't be troubling to see this because I know that this if you wanted to take the square root you need to first of
Oh,
all you have to add the numbers and then you have to take the square root,
yes,
right, in
yes,
this
yes.
case.
We have to write
So
it down that numbers. Another
yeah,
problem is
yeah,
you can,
yeah,
there
yeah,
is no
so that's
memory
what
and
I'm
all,
saying.
no?
Yeah, so there is no memory, so what I'm saying is just practice it on that calculator so that you will be familiarized with that calculator so that the chances of doing mistakes, right, it will reduce. So
Sir,
before
we
going to
have that
exams,
available.
right?
It's not taking
Sir, we
any
had that.
values keyboard. Is it true?
Yeah, yeah,
Yes,
yeah,
yes,
yeah. You have to do it by the mouse.
mouse.
That
That
is
is
the
also
hard
time
part.
taking. Time taking.
That's the hard part.
So yeah, that's what I'm suggesting you guys before going to the exam, right? Just TCS calculator is available online also. If you don't have this through the IIT Madras, I think it is there. But if you don't know, then go and type TCS calculator online on the your Google Chrome
Also,
and use
when you
that.
give the data, yeah, and also when you give the data points, no, let it be perfect squares like 100,
Yeah,
something
yeah,
like
yeah.
that. So
Correct,
that
correct.
we
Yeah,
don't have to use calculator. I mean, we can do directly. We can,
right, right. So here I'm seeing the numbers. So correlation coefficient, right? So answers are 0.878, 0.878, 0.878. So a lot of people are giving the same kind of answers 0.87, 0.87866. Somebody has given 1.87. Sakshi Kumari. Maybe it is due to, yeah, she said 0.87. Yeah, correct. So 0.87, 0.87. Yeah. So I think a lot of you guys have given this. Yeah, somebody has posted the link. So you can use the link, this link to, thank you, Siva Prasad. So you can use this TCS calculator. You practice there. So you will get, yeah, yeah, that is the link for this TCS calculator. So I think a lot of guys have given the 0.87 as answer. Still, how many are there? Okay, so others are they didn't get the answer or they want some more time to solve this. Because I'm seeing only maybe 20 answers here, not more than that. What happened to others? So Ram is saying, sir, can you tell me about slides? Can you please me? Okay, where to access the slides? So it will be there on the portal. I think the extra materials or something, it will be there, and you can find it there in your portal itself. It is there. Week 1, week 2, week 3, week 4. Below that, some extra contents or something is there. From there, you can just go and see. So yeah, so we'll move on to taking this solution. We'll see the solution. Okay. So I told you before, the correlation coefficient is calculated by somebody's having noise. Yeah. So correlation coefficient is calculated by the ratio of covariance of x and y to the standard deviations, the product of the standard deviations of x and y, right? So here the correct answer is 0.87, but there is a mistake here. It's not 8.29, it is 8.24, right? Because we have calculated in the previous slides, covariance of xy was 19.4. This is the sample covariance, right? So if I'll show you, so yeah, this was the sample covariance 19.4. Then if you use the sample covariance in the numerator, you have to use the sample standard deviations corresponding to x and y. So the sample standard deviations for x and y was 8.24 and 2.68. So here you have calculated R as 9, because this is sample covariance. 19.4 is the sample covariance, 8.24 is the sample standard deviation for x, and 2.68 is the sample standard deviation for y. So if you calculate this, you'll get the answer as 0.87. So the correct answer is 0.87, right? We'll move on to the next question. Okay, here also, here this is the different data set. So gender is given here and marks are given here. So this is the data for the some exam. So there are 5 persons, among which 3 are male and 2 are female. M represents male, F represents the female. So the marks of these people are tabulated here: 69, 75, 83, 71, and 67. So the question is, calculate the average marks corresponding to the gender. Right. So calculate the average for the marks. That is the question. So I'll give you 3 minutes to solve this, because now you know how to calculate the average of this, right? Just solve it. And give the answers in the chat box.
Sir, are we touching the topic of biserial correlation?
Yeah. So this question is related to this only, the point by series. So we are
Okay.
slowly moving to that side.
Okay.
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 Okay. Is it done?
Yes, sir.
Yes, sir.
No, sir.
Yes, sir.
Okay, somebody says no. Okay, okay. We'll take one more minute, okay? Then we'll move to the question. Okay, I think we'll see the solution. So it's just you need to take the sum of these marks 69 plus 75 plus 83 plus 71 and 67, and because there are total of 5 observations, you need to divide it by 5. So that should be your answer. So I know. Okay, I didn't see the answers. Sorry. Okay. So for male, it's 75.66. For female, is 69. 75.6, 69, 75.6, 69. Okay, somebody has written percentage. These are not the percentage. Bhavana, it's not the percentage, right? Okay, okay. I think, yeah. Okay. So we'll see the, I think most of you guys got the correct answer. So we'll see the solution quickly. So here you can see average marks for the male are, because see here are three males are there. So average marks for male are 69 plus 75 plus 83 divided by 3. So here 69 plus 75 plus 83 divided by 3, it should be 75.66. And the average marks for female are, because there are only two females in this data set, so 71 plus 67 divided by 2, that is 69. So the correct answer should be 75.66 and 69. So we'll move on to your next question. So the next question is calculate the proportion for both the gender from the given data. So this is fairly easy question. So just calculate the proportions for male and what is the proportion for female. So I'll give you only 2 minutes for this. Okay. Okay, guys, I will see the answers. So, okay, okay. I think I got a lot of answers here. 3 by 4 for male, 2 by 5 for female, right? Proportion for male is 0.6, 0.4, 0.37, 3 is to 2. Okay, 3 is to 2 is also correct only, but if you wanted to calculate the proportions differently, it should be 3 divided by 5 and 2 divided by 5. That means point 0.5 and sorry, point 0.6 and point 0.4. Okay. Female is 2.2 by 5. Okay. Okay. 3 by 5 and okay, somebody has written 62.2 and 37.8. Okay, I don't know what is how you have calculated.
It is
Can you
percentage.
just say
62.2 percentage, and it's a percentage. 62.2% and
if it is percentage
37.28%.
also? Yeah, okay, I understand, but what if it is in percentage also? It should be 60 and 40. How come it's 62.2% and 37.8?
Oh, this is the ratio of the male marks and female marks on the total marks.
Okay, you calculated the proportions of marks, you said,
Yeah,
right? I
yeah,
have
yeah,
asked you
yeah.
the question as what is the proportion of both the gender? Like how many
Oh,
males are there and how many females are there? So that's why it should be three males are there, right? Out of
yeah,
three
yeah,
males
yeah.
are there and
Okay.
five out of the five. So the proportion should be 3/5 for male and 2/5 for the
Okay.
female, right? Okay, I
When my
think
answer,
yeah,
when my answer can be correct only when it is asked as proportional
proportion
marks.
of marks corresponding to
Yeah.
these
Okay.
genders, right? But don't worry because
Okay. Okay.
this kind of questions won't be there because we are heading towards that week 4 the point by serial correlation coefficient. I have asked this question. Okay, it's not
Okay.
so I think fairly you guys know. So male proportion means how many number of males are there out of the total number of observations, right? So 3 divided by, because total we have 5 observations, so 3 divided by 5, which is equals to zero point 0.6, is a male proportion, and the female proportion is 2 divided by 5. So we are not going to waste a lot of time over this. Okay, and yeah, one more thing. If you consider male as 0, then we are representing it as p0, and then we are representing female as 1, so it will be p1. So p1 means proportion for female, p0 is the proportion of male, and vice versa. If somebody will say male as 1, so p1 will be the proportion of male and p0 will be the proportion of female. Okay,
Actually, in
so the
this,
same.
yeah,
Ah,
yeah. Actually,
yeah,
in this, I had the doubt actually whether n should be population or sample, because we don't know whether, yeah, we don't know whether this 5 data point is population or this 5 data point related to sample, because there is no statement.
right.
And
So but it
here,
doesn't
what
matter.
happened is, yeah, what I
Mm,
got
mm,
means I asked the doubt in the forum and I got the answer also. Can you go back to the next
mm,
slide? Can you go to the next slide?
mm,
Yeah, here the answer what I got is for either male you have to take as 5 means population, and one
mm.
for female you have to take it as sample, or vice versa. I don't, I am not fully
No,
convinced
no,
with
no,
that.
no. Okay, okay, I understand what you're saying is it is, I think it is related to the point by serial correlation
Yeah,
coefficient.
yeah, yeah.
The
Yes,
formula is
yes.
there. The final formula is there, right?
Yes, yes,
Okay,
yes.
I'll go to that
Okay.
whatever doubt is there. I'll go to that question also, but we'll see
Okay.
how it will evolve, right? Then I'll
Okay.
explain it. Okay, there, right? So
Okay.
for
Okay.
now, just okay. For
Okay,
now,
fine.
calculate the standard deviation of marks from the given data set. Okay, calculate the standard deviation of marks. So I will give and okay, for this we know the mean was 69. Okay, you need to calculate the mean again. Okay, so I'll give you 5 minutes from here to calculate the standard deviation of marks.
Yeah, here it is population or sample standard deviation.
So calculate population standard deviation here.
Can we consider as a population?
Yeah. Calculate the population standard deviation.
Okay.
Meanwhile, will this be the last session or any further sessions is planned?
So one session will be there for mock solid instructor, right? For mock paper.
That is the last one, is it? Mean in between, if
No, in
is
between.
it possible
No,
to
in
have?
between. Yeah. We'll have one session in between mock session and your final exam. So for statistics, we are planning to have a session in between mock session and mock paper and final exam. So that if any last minute doubt will be there, we'll solve that. Okay.
No, what my request is before the mock one session is there, it will be better actually because long gap.
Okay, we'll see. Mock will it won't be that long, I guess. Mock will be, I think, maybe 2 weeks after here.
It's on 21st or something.
So it will be both. There will be like
25th,
online
sir.
session of
April
each
25th.
subject.
What?
It is on
Actually, I didn't.
April. It is on April.
21st.
Yeah,
21st,
21st.
right?
25th, sir.
No, 25th is your final exam, right?
Yes, sir. Qualifier
25th
exam.
is yeah, and the mock will be 7 or 8 days before.
21st
So
and 27th, sir.
mock test. Yeah, so 21st and 22nd. Okay.
21st is maths and
Okay, then
CT.
then
22nd is CT, so statistics and English.
okay, so the before my mock will take one session. So maybe today is what date? Two, right? Second. So
Yeah.
let's suppose when okay,
Maybe on
we'll
15.
discuss.
Yeah, you can discuss. Yeah.
Yeah. 15 or 16. Yeah. So after 8 10 days we'll be having. Okay, fine.
Yes.
No issues. Yeah, we'll be having because we
Sir,
have to
the
take one
live
session.
session will only be for stats or like we will get live sessions for maths and CT too.
Actually, your voice is too. I don't know. I didn't get it.
I was asking,
Relaxation.
sir, that are we getting live sessions for maths and CT too before the mock exams?
Yeah. You will be having one session for maths and city also, I guess. But it depends on them, like how they are conducting that session. But it will be there. So stats
Okay.
it is there, it's confirmed. But
Hmm.
maths and city will also be having one session. So yeah.
Okay.
So maybe that 15 or 16 date, right? We'll be having one session there. Okay. Okay. So we'll see the solution now. I think, right? So how many of you got this answer here? Population standard deviation. Okay. So I'm seeing here 5.656, 5.65, 5.65, 65, 2.2, 5.65, 5.67, 5.66, 73. Okay, 5.65, 2.52, 5.65. Okay, I didn't ask you to calculate the sample standard deviation, calculate the population standard deviation. Okay, Shubhangi.
Yes.
Okay. Okay. Okay, I got around 20 responses, I guess. Other guys also please respond quickly. Are you able to solve the questions or what's the problem? Is there any problem in solving the questions?
No, sir.
So why others are not responding there? Like I'm seeing only 20, 21 responses.
Sir, one thing I'm asked to you.
Hmm.
Sir, in graded assignment, in the last, in the question number 1, write a correct up to 2 decimal accuracy.
Hmm.
Hello, I'm audible.
So you are audible. So the correct up to two decimal points means, like say your answer is around, like, for example, your answer is 7.687 something like that. So you just need to write six what sorry, your answer is, let's say, 7.623. So you have to write it as 7.62. That's it. You need not to write 7.623.
Okay,
Right.
sir.
That means you need
Hey,
to
sir.
give your answer into two decimal points. Okay.
Nee, there's one thing
If
is
you
just that question. My answer is 5.656854. So that
right. So
two
if you write
decimal
it
accuracy
5.65.
5.65 or you are 5.66.
So both will be accepted. Don't worry. So if you write 5.65 also or 5.66 also, both the answers will be accepted. But you have to write it as 5.6.
Hello. 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 Hello, sir, I am audible.
Yes, you are audible, but sir, I'm
I
muted.
think sir's audio is
Okay.
disconnected.
For this question is, if you calculate what is the x bar here? Can somebody
So 73.
75, 73.
3.
Yeah. So 73 is your x bar, right? So 69 minus 73 is -4, deviation, right?
Yes.
75 minus 73 is 2. So you know the procedure how to find out the deviations from the mean. So these are the deviations of the marks from the mean. Then you have to calculate this xi minus x bar to the whole square. So minus 4 whole square will be 16, 2 square will be 4, 10 square will be 100, minus 2 square will be 4, and minus 6 will be 36. You just need to take the sum of this. So 16 plus 4 is 20, 36 plus 4 is 40. So 140 plus 2, 20. That means 160. So total sum is 160 here. So what is so the answer here is, it is the sample standard deviation. Okay. I have asked you to calculate the population standard deviation. So the answer for the population standard, it should be 160 divided by 5, right? And root of that.
32.
Right. So root of 32. So square root of 32 is 5.65. So those who have given the answer correct as 5.65, it is your correct answer, because I have asked you to calculate the population standard deviation. And if I am asking you to calculate the sample standard deviation, it should be 6.32, because we are just dividing 160 by 4. Okay. So note down this number, sample standard deviation, as 6.32, because I didn't
Sir,
ask you to calculate, right? So just write it down there.
sir, one thing I'm ask you.
Yeah.
Sir, one answer is coming 0.89. So it should be right 0.89 or 0.89. Because in graded
Both are
assignment,
accepted.
two should be wrong from.
Yeah. In that grade assignment too, there was a problem, because in the back end we gave it as a string as a correct answer, but it should be numeric. If it is numeric, right? So both the answers will be correct. 0.89 also and 0.89 also. So that problem won't be happening in the exam. So if you write 0.89 also, it is correct, and 0.89 also, it is correct. Both are the correct answers. Okay.
Okay, thank you.
So the next question is find the point biserial correlation coefficient between gender and the marks. So I'm going to give you, let's say, how much time you want? Let's say 10 minutes. 10 minutes from here.
So do we need to use the sample standard deviation here, which is 6.32?
Yeah, if you can use that, if you are using the sample standard deviation in calculating point biserial correlation coefficient, use the sample standard deviation as 6.32. That's why I asked you, note it down that 6.32. Okay?
Okay. Okay.
Okay. Okay.
So you can explain the term biserial correlation.
Biserial means like see here, biserial means there are only two. Biserial correlation coefficient when we use is when we have one categorical variable and one numerical variable, right? And in this bi means we have in the categorical variable two categories. For example, in gender is a categorical variable here, right? So in that we have two different categories, that is male and female. So when we are finding out the correlation between this categorical and numerical variable, and we have these two categories for the categorical variable, then we called it as a point biserial correlation coefficient. Okay, so that is called dictomous variable. Dictomous means two different categories. So gender is a categorical variable, it is having two categories as male and a female.
Male.
Okay.
Okay, sir.
Hmm. So calculate the point biserial correlation coefficient. So until 4:25, I'm giving you the time. Then we'll discuss that question. And one more that doubt I will discuss, that when to use sample standard deviation and that population standard deviation. Then we will find a position.
Can we expect these kind of calculations in the qualifier exam?
Hmm. Yeah, you can see it might be there or it might not be. So if you have to but practice these questions, right? Because it might be there in the qualifier exams.
Yeah.
Here only I
If you do the
have this
practice,
doubt.
hmm.
Yeah, the doubt is if you use that population, no, we are using standard deviation, population standard deviation, and in the numerator we are having what do you call that proportion of male
Root of
is
the proportions, right?
yeah,
Yeah.
root of proportion of male is 3 by 5 multiplied by root of 2 by 5.
Right.
Yeah, but if you use the sample one, it will be
Hmm.
3 by 5 multiplied by 2 by 4.
Yes, correct. Yeah, it is
And
there.
denominator, it will come as
Sample standard
sample
deviation.
standard deviation. But both answer will
Right.
come same or how?
Same,
I
same,
have not
same.
tried it, but I will try for
Yeah,
this example itself. Okay.
yeah, because that's why I told you use this sample standard deviation formula. Because use both the formulas and you will see. You will
But my
be
only
getting the
doubt
same
is,
answer.
yeah, my only doubt is, what will happen if we do 3 by 4 multiplied by 2 by 5? We either one we have to use n minus 1, is it not? Hello.
Why would you?
Yeah, here we are only using n minus 1 only to calculate the standard deviation, right?
No, no, in the proportion, no, in the numerator.
No, in the
One,
proportion, there is no concept of using n minus 1.
no, no, it is there, it is there. That is where I am getting confused actually.
No,
No,
I don't think we
proportion.
should use
Yeah, sorry.
anything on the
Sorry, actually, I
proportion.
was. Okay, 1 minute, 1 minute. I was.
There are two
The internet
formulas. If
connection
you
was
are
lost.
using, yeah, there are two formulas.
Sorry.
If you are using population, then there is one formula where uh, no n minus one confusion is there. But if you are using sample, no,
Right.
then we have
Then we
to
have to use n minus 1.
n minus one in denominator and in the
Proportion.
numerator. Yeah, in the proportion also
Yeah,
we have
it's.
to minus. My only
Yeah,
doubt
it's
is,
there. It's there.
but my only doubt is, if you are using sample,
Uh,
what will happen if we use 3 by 4 multiplied by 2 by 5?
then also it's fine. Then also you will get the same answer.
Same answer will go. Okay, I have not
Yeah,
tried. Okay,
yeah.
I am trying now.
Only. Yeah, only n minus 1. Anywhere you can use that n minus 1.
Okay, but
Either with the
for
P0 but only in one n minus 1.
one place.
Not
Okay,
both.
okay, okay.
Right? Because that n minus 1 should get cancelled with that sample standard deviations n minus 1. That's the idea behind it. Your if you use the population standard deviation, you need not to worry about that n minus 1 there.
Yes,
So
yes.
there, yeah. So I will prefer that you can, if you use the population standard deviation to calculate the point by serial correlation coefficient.
No,
But
yeah, that is better actually. Yeah.
yeah, but if you if you calculated the sample standard deviation previously, then use the n minus 1 formula there and calculate it there, right?
Okay, okay,
So yeah, so but you will be getting the same answer.
okay, okay.
Either way, you can find.
So in this case, while creating the proportions,
Hmm.
if it is population, m proportion will be 3 by 5 and 2 by 5 for the
Hmm.
females, right?
Okay. Yes.
It
Correct.
is sample, you're saying 3 by 4 will be male and 2 by 4 for females.
No, no, no. When you are using the sample standard deviation, right?
No,
So
no, no. I'm
then,
not trying to use the sample deviation at all. I'm trying to
uh,
calculate the proportions of male and female out of all the list.
okay. So
So the
proportion, it will always be 3 by 5 and 2 by 5 if you see the P0. But if you wanted to calculate, if you have that samples, if you wanted to calculate the point biserial coefficient from the sample standard deviation, just can you mute yourself 1 minute because some noise is there. Yeah. So if you are calculating the populations, sorry, point biserial correlation coefficient by using the So when you are calculating the point biserial correlation coefficient by using the sample standard deviation, in the formula, see, the formula is the proportion how we'll calculate is number of observations in a category divided by total number of observations, right? Instead of that, you have to just subtract one from there, but not with the both proportions, only with one proportion. There is the change in that formula, right? But you should not say that then the proportion for this. Okay.
Yeah, actually here, if you understand correctly, the y1 minus y bar will not change.
Okay, it won't change.
Y2 minus y bar will not change, even it is a population or a sample.
Right. It won't change, right?
Yeah, only the bottom part, which is a standard deviation, only will change, whether it's a population
Yes.
or standard deviation.
Standard deviation. So if you use the population standard deviation there, then in the root of that proportions will be there, right? Root of 3 by 5 into 2 by 5. If you use the population standard deviation in the denominator, your that root of 3 by 5 into 2 by 5 will be there. And if you
Yes.
use the sample standard deviation in the denominator, then your answer will come out like by using this calculation, root of 3 by 4 into 2 by 5 or 3 by 5 into 2 by 4. You're getting my point?
Again, where did you getting the 2 by 4?
So n minus 1. See, proportion how you will calculate the number here in this example, let's say there are 3 males and 2 females, right? So what you are doing is 3 is and total number of observations is equals to n, which is equals to 5 year. N is equals to 5 year, right?
Correct.
So I need to calculate it by 3 by n into 2 by n. So instead of that, when you are using the sample standard deviation, use n minus 1 anywhere, like either 3 by n minus 1 into 2 by n or 3 by n 3 by n into 2 by n minus 1. So that n minus 1, n is 5 here, right? So n minus 1 will be 4.
No, when you're saying 3 by n minus 1, which is referring to a proportion, right?
Yes, proportion. Root of that I'm saying. Root of.
No, then why you're
In,
again you're coming back to the point 1. So here the proportions n minus 1 will not apply, right? That's what you clarified in the very first of my question. Again you're saying 3 by n minus 1. So there is no n minus 1 concept here.
No, sir. What he is trying to tell you is, if you are using standard deviation, then that n minus 1 concept means population standard deviation, then the concept of n minus 1 won't come.
Yeah,
If you are-
only
yeah.
it will not. But whatever the proportion, even for the proportion also will it come?
Even for proportion also. So actually the formula
be
is
there.
very clear. We will use only population standard deviation. The confusion will come if you are using sample standard deviation.
Standard deviation.
If you're
Yes.
using sample standard deviation, then in the
Then
numerator
it
we
will
have
change
got the
to n minus
proportion.
1.
Yeah, we have proportion. So in the proportion,
Then it will
any one we have to
different
use n
answer.
minus
It is
1.
not the same answer.
No, I got the same answer, sir.
Same, it will get same answer.
Same
you will
answer.
Get same
For
answer.
all three, I checked right now. I got the same answer, 0.578. But only thing is, if you're using sample, this one standard deviation in the numerator, we have to use in the proportion. Either one, we have to use n minus 1, not both.
Hold on. But what is the right answer here now? What is the right answer?
0.578. That is what I got.
That's
Whether it
not-
is right or wrong, I don't know.
That's not the answer I got it. I got 0.516. That's what many people have dropped there.
That is correct. That is correct. For the sample, it is 5145 I got.
Yeah,
For the
same,
population, for the population I got 566. I mean 0.5664.
Yeah, I'm
No,
getting
no,
a
no.
different
Your
answer.
answer
That's
should
why.
be same. Why are you are getting the different answers? The answer
Let's
should be
go
same.
through the. Let's first go through the answer. What you have worked it out.
Okay. Then we'll go to the solution, right?
Yeah.
I'm okay. So this here it is a save. First step is group the data into two sets, right? That means your y will be the gender, right? I'm saying this gender as y. So there are two, you see, two variable, like because it is a dictomous variable. So there are two categories, one is male and another one is female. So I am considering it as gender as y. So y1, I'm representing uh, y0 as the male and y1 as the female here. Okay, y0 as the male and y1 as the female here. Okay, now calculate the mean values for these two groups. So two groups, that means two categories, one is male and another one is female. So if you calculate the y0 bar, that is mean for males, and so mean of the marks for males and mean of the marks for the female, that is y1 bar, right? So what is the value for that? If you calculate, can you some? Okay, tell you the answers for that.
75.67
Yeah,
and
tell me.
69.
75.66.
75.66, correct, or 75.67, and this is the
67,
the another one. So you can consider it as
69.
y0 bar. Okay,
69.
yeah, it should be 69, correct.
Yeah.
So these are the two. This, that is your y0 bar is the other value, and this y1 bar is the 69. Okay, let p0 and p1 be the proportions. Now I have represented male as 0 and female as 1, right?
3 by 5 and 2 by 5.
So right. So what is the proportion for male?
3 by 5.
Proportion for male will be 3 by 5 and proportion for female will be 2 by 5. So what I'm saying is, if I'm using the population standard deviation, this is the formula for the point by serial correlation coefficient, right? Y0 bar minus y1 bar upon sx into root of p0 minus, sorry, p0 into p1. So here if I'm using the population standard deviation, the denominator sx, if I'm using the population standard deviation here, I will be using p0 as 3 by 5 and p1 as 2 by 5, as it is what we have calculated, correct? And y0 bar minus y1 bar. But if I'm using the sample standard deviation here, sx, then I will be using p0 as 3 by 4 into 2 by 5, or 3 by 5 into 2 by 4. Any of the values should be 5 and 4 in the denominator.
How come it is 2
If
by
I'm using
5? 2 by 4 into 2 by 5. How it is possible? The proportions?
see proportions, see, if you go the that what do you say, definition wise, what is the definition for the proportion? You will be saying these are the observation divided by total number of observations, right? But in this
Correct.
formula, it is not, you can say p0 is some number and p1 as some number, don't say as the proportions. Okay, so how we are calculating here is number of observations for the one category divided by total number of observations into number of observations for the second category divided by total number of observations is my proportions, when I am using the population standard deviation. But when I am using the sample standard deviations, in that root, the p0 should be number of observations for that category divided by total number of observations into number of observation for the second category divided by total number of observations minus 1. Okay, don't go definition wise, I'm saying this is the formula. When you are when you are using the sample standard deviation here, you have to use this formula. That means number of observations for the first category divided by total number of observations, that means n, into number of observations for the second category divided by total number of observations minus 1, that means n minus 1. That means 5 minus 1 here equals to 4. Okay, don't say like, okay, this is the definition for the proportion and I'm going to use it like this. I'm saying that this is the formula you have to use. Okay,
Sir,
you are using the sample standard deviation.
No, I think it's a bit confusing than the lecture. This concept even is not discussed on the lecture itself. So proportion is always, I mean, the P1 plus P1 always equal to 1, right? Even
See,
in the, if
that's
you
what
take,
I'm saying. Okay, okay. If it is confusing to you, okay, what we will do is, while calculating the point biserial correlation coefficient, uh, use the population standard deviation in the denominator, so that your proportions will be the same as you are thinking. Correct?
Yeah,
Sir,
that I am clear. But what about the sample?
So, so don't
Calculation?
use the sample standard. If you are confused with that, right? Don't use the sample standard deviation. If you wanted to use the sample standard deviation, use n minus one in the denominator, because this formula is derived. See how it is derived. If you use the sample standard deviation here, sample standard deviation is summation of these things, right? Xi minus x bar square in the root. I'm saying x minus x
Yeah,
bar whole square divided by n minus one. Correct?
correct. Hmm.
And if the population standard deviation, it is summation of xi minus x bar whole square divided by n.
Yes,
So, and in the that square root, if you are using the proportions, it should be sorry, it should be like divide in the denominator, it should be n into n, that means n square, right? So that n will be getting cancelled and will be getting the same answer. But if you use the sample standard deviation, the denominator will be n minus 1 to get cancelled that n minus 1. So that from that numerator we are using n minus 1 there in the proportions, because this
uh,
point by serial coefficient, correlation coefficient is nothing but your normal correlation coefficient only, but it is changed accordingly to, so that it will like, so that it should
So
be
the formula.
validated for this category.
no, I think here my specific question about the proportions. So how the proportions will change based on the sample or a population?
See, that's what I am saying. Don't consider it as a proportion. When you are using the sample standard deviation, don't consider it as a proportion. You have to use this n minus 1 if you are using the sample standard deviation. And if you are confused with this, because I'm not going to in details how to derive this formula for the from the correlation coefficient. There is a derivation for that. So if you are not able to understand what I'm saying, use the population standard deviation in the denominator, okay, and use the same definitions of the proportion what we are using, that is number of observation divided by total number of observations. Fine.
Okay.
Okay.
So it will be easy, right? So there won't be any confusion. So to avoid the confusion, use this formula uh, of this point by serial coefficient as y0 bar minus y1 bar divided by population standard deviation into root of p0 into p1. So the p0 here will be 3 by 5 and p1 will be 2 by 5.
Correct.
Right? Okay.
Sir, what if mean difference is
So
negative?
y0 minus y, so your value will be minus something. So in the exam paper, if you are in the exam, we'll be asking you the absolute value of the point by serial coefficient. So some of you will be getting the positive value and some of will get the negative value, but it is of no difference. These both values represent the same thing, because someone will consider 0 as male and 1 as female, or somebody will consider 0 as female and 1 as male. So accordingly your values will be changing. That minus sign will be changing, but the answers will be the same. If you don't consider those signs plus and minus, your value, that point something 516, right, it will be same. So
There won't
if
be
in the
same.
exam we'll be asking what is the absolute value of the point biserial correlation coefficient, so that everyone will be getting the same answer, because absolute means you will be removing the signs. Correct?
Okay, if question is absolute, then we don't have to use any sign.
Sign, yeah, even if your answer is minus 0.51, you have to
Mhm.
answer, you have to write your answer as 0.51. Absolute means you have to remove the sign. Okay.
Okay, okay. Thank you, sir.
Yeah, and in both ways you will be getting the same value, but the sign will be different. Okay. So here, yeah. So y0 bar represents the mean marks and y1 represents the mean marks for female, right? So here 0 represented for the male and y1 1 represent for the female. So p0 is a proportion of male and p1 is the proportion of female. Right? So y0 bar is 75.66, y1 bar is 69, and the proportion corresponding proportions are zero point 0.6 and zero point 0.4 here. Okay. So you have to just here, this is the sample stand. Okay. So this value,
We need
okay,
to
fine.
use 5.65 as
Yeah.
a definition.
Yeah. So just a minute, I'll just check once. So yeah, here the answer written here is wrong. So you have to use root of 32. That is
Is the answer
5.65.
0.2?
5.65 we
So
need to use.
yeah, 5.65 you need to use. So the answer should be
5.6.
6.66.
Yeah, 4.
So no, 6.66 divided by 5.65, right? Into 0.49. So your answer, the correct answer should be 0.577 or 5.57, 0.58 something. If
No, the
you
answer
are
will
considering,
be 0.56 or 57.
yeah, it's fine.
0.5.
0.56 or 0.57 or 0.58.
Yeah.
Because if you use the different how many digits you are using for the calculation, accordingly your answer will change. So it should be 0.57. Okay.
Yeah.
Yeah, here it's written wrongly. It should be here. You are if you are using the sample standard deviation, you need to make changes in the proportions. So you have to use 5.65 here instead of 6.32 in the denominator. Then you will be getting this answer. So I'll be correcting this changes in the slides before giving you the slides. Okay.
Actually, I got
Sir,
the same
because
answer if I use the sample standard deviation. 0.5145. That is where I asked the earlier question. Will the proportions will
Yeah, but
standard
yeah,
deviation or not?
proportion will be changed. No. But if you are getting this 0.515, you will be you had I think you have used this point 0.6 into point 0.4 there, right, in the proportions, but that
Yeah.
is wrong.
Yeah.
Yeah.
Exactly. Yeah.
There you need not to. Yeah, there you need not to. So then I told you na you have to use the n minus one there. So you need to have 3/5 into 2/4. That means 6 by how many? 6 by 20. You have to use root of 6 by 20 there. I don't know how much it is the value. Six. You
that
try with this.
0.3, that's 0.54.
Huh? Six by 20 is
0.54.
0.3.
Yeah, so
Okay.
square root of 0.3 is 0.54.
Yeah.
Yeah. Square of and then use this calculation. 1 into 1.053. 1.053. So
Yeah,
you'll
it
be
is.
getting again 0.57.
Sir,
Right?
it won't be 1.053 because the denominator will change, no, sir.
It's
No, no.
Yeah,
0.67.
See,
denominator will change to 5.65.
0.567 will be the answer.
yeah. See, here the slide you are seeing it is wrong only because here what you have used is sample standard deviation. 6.32 is the sample standard deviation. So if you use the sample standard deviation here, then you have to multiply with the 1.503 by 0.54. Then your answer will be 0.57. If you are using 5.65 here instead of 6.32, then your answer should be 6.66.
Into
6.66 divided by
0.64.
5.65 into that means 1.17 into 0.49. Again you will be getting the same answer. So the correct answer you should be getting is 0.57.
Okay, sir.
Yeah.
Okay.
So then the both answers will be same, even for the sample and the
Same.
population will be
Yeah,
same.
it should be same. It should be same. Yeah. Hmm? Okay, then I will make the changes before sending you this PPT to you. Okay, you guys clear with this, right?
Okay.
So and okay, while in the exams use population standard deviation instead of sample standard deviation while calculating this point by serial coefficient, so that that confusion won't be there. That in minus one. Okay. Okay then.
Yeah.
Bye.
Thank you.
Okay, guys. Yeah. Thank you, guys. Bye bye. So I'm ending this meeting.
Thank you. Bye.
Sir, where we
Thank
can
you.
view?
Sir, when you will upload the PPT, sir?
Maybe tomorrow morning.
Okay.
I will make changes in this PPT and then I will upload it. Okay.
Okay, sir.
How
Sir, I'm
can
getting
we
the
view?
answer as
How we can view this
0.64, sir.
PPT?
I will be sending. Okay, I will be this PPT, right. I will be using both the formulas. I will add one more
Okay,
slide
sir.
into it, and I will be giving you the answers of both. Okay, how I have
Okay.
calculated. right?
Thank you,
That
sir.
will be
So
good. That
Thank-
will be good.
okay,
Yes.
fine. Yeah, I will add one more slide to this with the sample standard deviation and with the population standard deviation. Okay.
Okay,
Okay.
sir.
Okay. Okay.
Thank you so
Okay.
much.
Bye.
Thank you.
Okay. Bye, guys. So yeah, and one more thing, you will be getting these slides into that. Yeah, you you can access those slides into your portal itself. There is week 1, week 2, week 3, week 4, and below that extra contents will be there. You can access it from there.
Good.
Yes, sir.
Okay. Okay. Bye. Bye, guys.
Okay.
Thank you for.
Bye.